All right, review day for the test. We'll be having a test and it'll be due Monday at 11:59 p.m. You can email me, you can share it with me through a Google Doc, you can handwrite it and take photos, whatever's your pleasure. I'm happy to help. So, we're going to be solving for unknown variables. Leave solutions as simplified radicals if needed. No long decimals like square root of 7 or whatever. No decimals unless it actually ends. Okay? So, for example, let's say I give you this information. So, this is the most accurate that it will be on the test. It'll be a 90-degree angle. It'll be one angle, usually 45, 60, or 30. And I'm going to give you one of the side lengths, and you're going to solve for the other two sides. So we know side length 7. We don't know side length W or Z, but what kind of triangle is this? 30, 60, 90 or 45, 45, 90? 45, 45, 90. So I'm going to do this problem in two ways, but I'm going to start with the same first step. So since this is a 45, 45, 90, what do we know about the legs of a 45, 45, 90 triangle? It has to be, they have to be congruent. So these two side lengths are congruent. So W is equal to 7. Okay? Now, let's say I want to solve for Z using trigonometry. I draw my Z's with the line through it so it doesn't look like the number 2, but I think I messed that up. But anyway, so solve for Z. Well, from what I know, the cosine of 45 degrees and the sine of 45 degrees are both identical. So what I can do is do either the sine or the cosine, but let's just say I'm consistent. I know that I have a 45-degree angle. I've got 7 and I've got Z. 7 is the adjacent side and Z is the hypotenuse. So therefore, I'm going to use the cosine of 45 degrees is equal to 7 over Z. And I look at my formulas. The cosine of 45 degrees is 1 over the square root of 2, which is proportional to 7 over Z. Now, I cross multiply, and I get 1 times Z, or 1Z, is equal to 7 radical 2. And I can't simplify this any further, so Z is equal to 7 radical 2. Okay? W is 7, Z is 7 radical 2. And if you don't like that method, I'm not going to take away the quadratic formula from you. So I am going to start with the same first step. My biggest hint in a 45, 45, 90 triangle is that the legs are congruent. So we know that W has to equal 7 because the legs are congruent. In a 45, 45, 90. Okay? Now, I'm just going to update this right here and just say that this W is equal to 7, and I want to solve for Z. I'm going to use Pythagorean theorem. I'm totally okay with you guys using Pythagorean theorem. So, by Pythagorean theorem, we've got leg squared plus leg squared equals hypotenuse squared. 7 squared is 49. 7 squared is also 49. So 49 plus 49 is equal to Z squared. 49 plus 49 is 98. which is equal to z squared. And now we square root both sides. And now we can simplify this radical because we've got z now. So radical 98 can be broken up, I guess, into radical 2 times radical 49. Hey, it's a perfect square. Take advantage. So that's 7. And I can't break down radical 2 anymore, so that's 7 radical 2 is equal to z from the Pythagorean theorem. It's the same thing. One of them involves trigonometry, trig ratios. The other one, well, Pythagorean theorem is still trigonometry, but Pythagorean theorem can be done. Trig ratios can be done. I don't have a preference. Okay. Number 2. What if I give you this diagram? I give you a 90-degree angle, a 60-degree angle, side length 14, and I want you to solve for t and u. Okay? Well, in my diagram, if I give you a 60-degree angle and a 90-degree angle, that's a big hint that this angle over here has to be 30 degrees. So I like to put myself in the driver's seat. I like to be in control of these kinds of problems by giving myself as much information as possible. So let's say I look at this. Let's say I look at 14 and I want to solve for u. So let's say I look at 60 degrees and I want to solve for u. Okay. So I've got 14, I've got u. 14 is the adjacent side, u is the hypotenuse. So which ratio involves an adjacent side and a hypotenuse? The cosine. So the cosine of 60 degrees is equal to 14 over u. And I look at my formulas. You know what else I could have done? The sine of 30 degrees. The sine of 30 degrees and the cosine of 60 degrees are exactly the same. What they tell me is that the ratio of an angle's adjacent side of 60 degrees to its hypotenuse is 1 over 2 is equal to 14 over u. And now I'm going to cross multiply. So now I get 1u is equal to 2 times 14, or that u is equal to 28. And it makes sense because in that definition, in that model that I gave you, the opposite side of a 30-degree angle is half the length of the hypotenuse of the triangle. So u is 28. Now, let's say I want to solve for t. There's a variety of ways I can solve this. So I want to solve for t. Let's say I know I want to solve for t by using t. So I look at 60 degrees. And I've got t, and I'm going to play with 28. T is the opposite side of 60 degrees, and t is the hypotenuse of the triangle. Which trig ratio involves opposite and hypotenuse for 60 degrees? Right, I'm going to use the sine of 60 degrees is proportional to t over 28. So therefore, the ratio of, if you look at your formulas, you'll notice that the sine of 60 degrees is radical 3 over 2. So radical 3 over 2 of t over 28, I'm going to cross multiply again. And I get 2t is equal to 28 radical 3. And then I'm going to divide both sides by 2. And that gets me t equals 14 radical 3. Okay. And again, what if you don't like that method? Well, here's another way you could approach this. So let's say I rewrite that I've got a 30-degree angle over here, and I make a little note to myself and I say, hey, the opposite side of 30 degrees is 14, so the hypotenuse, u, is actually equal to 20. Because the opposite side of a 30-degree angle is half the size of the hypotenuse. So in whatever words you like. So the opposite side of a 30-degree angle has to be half of the size of the hypotenuse. Okay, so u is equal to 28. And again, am I going to take away Pythagorean theorem from you? No, because in this case, leg squared plus leg squared equals hypotenuse squared. So I'm going to solve for t by doing Pythagorean theorem. I apologize, I don't know what 14 squared or 28 squared are. 196, 784. So now I'm going to solve for t by subtracting 196 from both sides. T squared is equal to 784 minus 196. 588. Okay, let me just scoot up a little bit. Okay, so if I square root both sides, now I've got t equals the square root of 588. Let's just say I divide that by 4. 147. Let me just make sure really quick. Let's just say I divide by 588, divide by 16. Can I divide by 16? No, I can't divide by 16. 588 divided by 12? Yeah, 12. Yeah, radical 12, radical 49. So that would be radical 4, radical 3, and I'm going to pull out a 7 here. And that's going to be a 2. So that's 2 times radical 3 times 7, or t equals 14 radical 3. Same thing. Okay, so as you can see, I'm trying to show both methods just to make sure you guys understand it in both directions. But I'm not going to lie, I love me some trig. I love trig functions. They're kind of straightforward. You got a proportion, boom, you're done. So I'm going to stick with the trig functions for the next 2 problems, and then we'll call it a day. So what if I give you this diagram? You've got 32, you've got 45 degrees, you've got 90 degrees, and I want to solve for side length A and side length B. Okay? Well, I'm going to make a little note to myself. It's a 45, 45, 90. So that means that A and B need to be congruent. A is equal to B because the legs of a 45, 45, 90 are congruent. Okay, so let's just say I solve for A. I'm done, basically. Or you know what? Let's just say I solve for b. Let's say I look at the 45-degree angle. I've got b and 32, and I mean this blue one right here. So I've got b and 32. Let's say b is my opposite side, and 32 is my hypotenuse. What trig ratio can I do? Yeah, I could do sine or cosine, but in this case, I'm picking this particular angle to figure out the sine. The sine of 45 degrees is proportional to b over 32. So now I'm going to go back to my 45-degree angles, and notice that the sine of 45 degrees is 1 over the square root of 2, which is b over 32. And now I'm going to get my green and cross multiply. Radical 2 times b is equal to 1 times 32, or 32. I'm going to divide both sides of the equation by radical 2. And b is equal to 32 over the square root of 2. And if b is equal to 32 over the square root of 2, and a is congruent to b, then a also has to equal 32 over the square root of 2. Okay? One more problem and we'll call it a day. So I give you a 30-degree angle. I give you a hypotenuse of 80. And I want to solve for, and a 90-degree angle, of course. And I want to solve for side length A and side length B. Well, in order to make this a triangle, 30 plus 90 plus what is 180 degrees? That has to be a 60-degree angle. So I have options. But you know what piece of information is the most valuable to me? The opposite side of the 30-degree angle. Because remember, the opposite side of the 30-degree angle should be half of the size of the hypotenuse. So let's say I want to solve for A. I'm going to look at 30 degrees. I've got A and I've got 80. The opposite side of 30 degrees is A. The hypotenuse of the triangle is 80. Which trig ratio involves an opposite and a hypotenuse? So, the sine ratio. Sine of 30 degrees is equal to A over 80. And if you look at your formulas, the sine of 30 degrees is 1/2. 1/2 is proportional to A over 80. And I'm going to get my pen. I'm going to cross multiply. I'm going to stick it in black now. So 2A should be equal to 1 times 80. 1 times 80 is 80. I'm going to divide both sides of the equation by 2, getting me A is equal to 40. Right? And now I'm going to solve for B. I could do Pythagorean theorem if you really wanted to, but you know what? I love me some trig. It's okay to like trig. I like the quick method. Solve for side length B. Once again, I have a variety of options to play with, but I'm going to look at 30 degrees. I've got side length B and side length 80. Side length B is the adjacent side, And side length 80 is the hypotenuse. I wrote it twice because I was going to do it in two separate ways, and I was like, no, I like trig. I like trig. That's the adjacent side, and 80 is the hypotenuse. Which trig ratio involves an adjacent side and a hypotenuse? The cosine. So the cosine of 30 degrees is proportional to the diagram b over 80. So I've got b over 80. And the cosine of 30 degrees is the square root of 3 over 2. I'm going to get my green and cross multiply. So I've got 2 times b, or 2b or not 2b, equals 80 radical 3. I'm going to divide both sides of the equation by 2. And so b is equal to 80 divided by 2 is 40, and I've got a radical 3. So in this final solution, a is equal to 40 and b is equal to 40 radical 3. If you have any questions, please email me, but the test is due Monday at 11:59 p.m. Good luck.